So the talk's called A Test of Strength, and most people who know me, I like a nice play on words, and the title's kind of no exception. It's kind of a game of two halves. There's a bit around the kind of test in terms of what it means to write strong tests, the kind of the practical aspect. And then also there's kind of, I'm sort of covering a kind of the more kind of psychology side, the kind of the more motivational aspect of it, which is about, what do we as a people need to be strong to kind of even consider writing tests in the first place, because it's not always the first thing we might choose to do, I guess. I kind of said it was a therapy session, and it's the first part is kind of a bit of a walkthrough journey, kind of where I went wrong, or things that kind of affected me. And hopefully that will kind of maybe feed into where you are along your kind of like decisions around testing and stuff. So to sort of borrow a nice phrase from Dan North, actually, when I started out developing kind of 20 years ago, I was working on graphic software, desktop applications. There was no kind of automated testing and tools kind of like we have now. But there probably were some really expensive ones like James kind of mentioned. But effectively, the features that we kind of worked on, they were the bits that you were concentrating on. So the tests that you were involved with were just the scenarios you cared about. Things like regression testing and things outside of your control, you had a QA department for that. You didn't need to worry about that. So everything kind of like, fitted in your head. So kind of that sort of manually approach kind of sort of worked to a degree around kind of small applications. And at this first place, I got introduced to a couple of books by a guy called Steve Maguire. There was definitely some snarky comments back in the 90s about the fact that somebody from Microsoft could have the gall to write what it means to write solid code. But certainly the kind of C applications in the world that I was working in, it had a big effect on the code base. And some of the practices around kind of design by contract that you kind of introduced was certainly very successful. One practice in particular that he talked about was using the debugger to step through new code that you've written or when you've changed stuff. So you kind of like put a breakpoint on your code and then you kind of like step through it, check your conditions and and loops and make sure that it exited and that it acted as it you expected. And that was kind of, I suppose, the sort of the unit testing of its day really. And again, that was quite a successful practice for kind of like at least writing code that kind of did what you expect it to, even if it didn't necessarily do what the kind of customer wanted. So that kind of formed the basis of certainly the way that I kind of tested software for quite a few years. Until I went to work at a broker's in London. And one day a colleague kind of came over and tapped me on the shoulder and said that this licensing component that we'd written was some tests were failing. First of all, I didn't even know what these kind of like tests were, but he kind of like muted the fact that there was these tests that ran that he was just playing with. But some change that had kind of gone into the code had effectively broken them. And I mean, he was being polite. He'd clearly gone in, he'd looked at the change, he could see that I was the last person who dabbled with the XML parser, because you used to write your own XML parser in those days. And I'd made a very small mistake in this sort of huge refactoring that I'd kind of done. Despite being really careful, I'd left out a call to one of the methods in the parsing that turned entity references into the into their single characters like ampersands and less than. And he had a test that basically had a license which had one of these funny characters in, and consequently it had broken. And I think at that point it was a bit of a kind of a watershed moment. I'd realised that this approach that I'd kind of taken, no matter how careful I kind of tried to be, how comprehensive I tried to be in terms of testing the areas, software just got too big to deal with anything. I mean, it kind of like way past, but I think sort of personally, I kind of still felt that I could carry on plugging away at the same thing. It might just take longer and longer, but ultimately that wasn't the right kind of approach. So naturally I asked my colleague and said, what's this testing thing you're talking about? And he'd used Michael Feathers had ported JUnit to C++, and he came up with CPP unit. So this is just an example of some CPP unit tests. I definitely liked the aspect of regression testing. I like the automated aspects of that. That felt like it was a very valuable pursuit. We could stop worrying about some of that side. But naturally, this code is so verbose. It's like there's just so much of it. And the thing that I found quite, that didn't sit right with me was the amount of time I would spend writing test code. And I felt like I wasn't paid to write test code. Not that because I was a developer, but just that, I felt like I was paid to deliver features, not paid to kind of test those features. So it felt like I was spending too much time doing that. And therefore, Michael Feathers is probably a really clever chap, but you know what, I can do better. Because, like all developers, we can optimize the way, we can tackle this. So I decided to optimize the way to write tests. So this quote from Tony Hoare about premature optimization is usually used in the context of code and how fast it runs. But John Carmack of ID and Doom fame, he pointed out that we can prematurely optimize other things as well, like flexibility and security and robustness and maintainability. So all the kind of, those ilities, those other parts of the process, we can find ourselves optimizing for the wrong thing there too. And that's exactly what I ended up doing. I ended up writing my own unit test framework for C++, and I ended up writing behemoths like this. So this is an example from my Git repo. If you dig back far enough, you'll find it. Dirty laundry is there for everybody. And even if you can't read C++, it doesn't matter. It should be fairly obvious that that's quite impenetrable. You have no idea what's going on in that. But when I wrote it, I was really pleased because I'd written it really quickly and I'd tested loads of stuff all in one go. Of course, when I came to fix a bug 6 months later in my command line parser, I had no idea what any of that meant. And therefore, I had no idea what I was really testing and what I would be fixing, and things would break. Now, if you think that I didn't fit the title or the name of the test on the slide because it didn't fit, no. One of the optimizations I made was you don't have to put a name into the test. That's really hard and takes a long time. So let's not do it because it's quicker to write, makes the whole process quicker. At least that's what I thought was a good thing to do. So you've seen this already, although James commented out the rude word and I haven't, so I apologize for the thing. This is, it's nearly 10 years old now. But the only code quality really is WTFs per minute, really. And that doesn't just apply to production code. I think it applies to test code as much as anything. And so I coined the phrase weak test functions as WTFs. And if you think I started with an acronym and worked backwards, you'd be entirely right. So, all this kind of getting into unit testing and automated testing, I started to kind of see patterns around things as time went on, going back over tests and seeing. Started to see patterns, certainly within my own tests and code, and reasons why I couldn't understand, reasons why they were failing. And these are some of the things that I kind of consider smells within the base, within tests that kind of tell us that maybe our quality aren't quite as good. So multiple responsibilities you saw in that example before. There were many things that we were testing all in one go. Not quite sure which ones were and weren't covered by that. No clear intent. It's not obvious what any specific thing is actually doing. Everything's kind of like welded kind of together. People who take on mocking frameworks usually go bonkers straight away, and you suddenly find tests are 90% setup code and verification, and the meat, the bit that's like kind of really important to the behavior, just kind of get lost inside a haze of other kind of stuff. So again, there was lots of incidental details in that in those tests. Correlation does not imply causation, and yet sometimes we come across tests where somebody's observing a side effect and saying that because this thing over here happens, this thing over here must have happened. Maybe it's sensing a log message to say that a call was made, rather than actually trying to mock and make the call appropriate. So, so kind of like not actually, the test not actually doing what it, testing the behavior that's going on, but sort of something that's kind of related to it. Naturally, tests are, there's a balance between a test that should be written well enough that it only fails to tell you something important versus a test that's so weak that effectively it wouldn't fail unless like the entire world collapsed around it. And there's a balance kind of between those two things. And that I think that takes a fair bit of time to kind of get over. But there are a number of, again, little patterns that we see where tests are definitely kind of too tightly constrained. They don't give us the wiggle room to refactor. To do stuff, which I think James covered. And then the last two are kind of sort of closely related, non-determinism and resource management within tests. in our production code, we often have scenarios where we expect things to live for the entire application, or we can make use of clocks and things because we're after the real time. Whereas when we're in our kind of test world, we need to get it into a very tightly constrained environment, and we need to do that many, many times. So they live in slightly different worlds. And if we don't kind of manage those resources and manage that determinism, then tests start randomly failing, and then, totally, maybe it's one test that fails 1 in 10 times, 1 in 100 times. Then it starts getting commented out, and then effectively gets deleted or ignored, or other tests that randomly fail because of side effects that have leaked across from different effects. And so taming those kind of helps us to keep a healthy kind of code base. So that kind of, I kind of reached this point where I thought, okay, I like this automated testing stuff, I like this unit testing, acceptance testing, but I'm kind of, but I'm over that now. I'm kind of over that bit where I'm a bit wary of the fact that writing tests are valuable, because I'm beginning to see the sort of, if you like, the benefits of doing it, and that actually maybe I am paid to write tests, not directly, but I'm paid to deliver code in a kind of sustainable way. So, things started to kind of change for me. I sort of picked that up. And then a number of things kind of in the last sort of 10 years have started to kind of shape that for me a bit more. And thinking more about the kind of like the longer term effects of how we use tests within our code. I'm going to look through more about playing the long game rather than kind of like fix it. Okay. So you won't know who this guy is, but he's going to look vaguely familiar to you. And that's because he's my dad. So, although annoyingly, he's only a couple of years older than me, and I'm the one with a full set of grey hair, and he's still got full colour. So I don't know how that happened. But anyway, he wasn't a programmer. He was a bookkeeper. So he used to manage accounts for various companies. And like many people of his generation, he was he was great at mental arithmetic. Generally, kind of avoided calculators because, as far as he could see, people would make mistakes with calculators as much as they could, adding numbers up. But he was. He kind of had, in his job, it was an important part that he kind of made sure that things added up correctly, that the books were balanced. And so, there are a number of little things that he kind of, I remember him sort of, doing when we were sort of doing maths homework and stuff together. He would kind of like teach me how to, the fact that when he added his numbers up, he might add them up top to bottom first of all, and then to kind of like double check his work, he would then not add them up from, say, bottom to top. Or he might pick every other line, or he might kind of group numbers together. But ultimately, he would find different ways to do the same task, but to come up and ensure that things were kind of working. One of the things that he would do was often kind of pull back and try and convince me to sort of look over my answers and come up with either even just using heuristics to see whether that kind of like made sense. Of course, being the son and being a teenager and, parents know nothing, I clearly ignored him and I was just running on to the next shiny thing. I'm not interested in all this kind of like double-checking, verification-y stuff. Hey, let me get on to the next question. That's the exciting bit. And then, of course, you realise, like, 20 years later that actually you probably had a point and I probably should have listened to him, but hey, we all make the same mistake kind of thing. But essentially, it's about redundancy within it. James talked about duplication, and it's not about kind of like duplication in the sense of it's the same code, but actually there is an element of within the tests that we write that there should be some duplication, either within the language or within the algorithm that we use to kind of finding other ways to double check what we're doing. We might use a slower algorithm in the test because it doesn't matter, but it's a way of double checking that things are kind of working. So there is an element of redundancy, and we should not misinterpret dry inappropriately. He's not around, unfortunately, anymore, but luckily social media is. And this tweet from J.B. Rainsberger seems to crop up on regular kind of, makes a regular appearance. And I'm kind of glad it does because, it's one of those reminders, every so often that, actually we should take our time, we should maybe slow down. Sometimes we do need to get things done, but more often than not, actually, let's just, chill out for a bit and just think a little bit more about whether, are we doing something for the kind of the short term or the kind of longer term. And particularly, practices like TDD and help you kind of, take a little bit more time around what things, because we're after some, a sustainable pace. One book in particular that certainly had a big effect on me was this book by Michael Feathers, who kind of crops up again, realised that maybe actually he did have a point with CPP unit at that point, and I probably dismissed him. But I'd read TDD by example, Kent Burke's book, and I'd also read David Astle's A Practical Guide to Test-Driven Development. And they were both kind of quite interesting and everything, but the problem was I wasn't working in greenfield projects. I wasn't working in languages like Java where you had reflection. I was working in knee-deep in 10-year-old C++ code bases where there were no tests whatsoever, and that's kind of a very different world. And this book came out, and that was the first book that really kind of spoke to me in the way that I was, the environment that I was in, things that I had to deal with. But even today, I mean, it's 10 years old, I think. I'm not the only one, I'm sure, that's badgered him to update it. But even today, I think, even if you're still not working in those kind of environments in legacy code, there's still a lot in the book that's hugely important as you think about code bases as they evolve over time. So I think that's a really important book. One thing that the book brings out is this idea from the hardware world around design for testability. They got to this point where chips are too complicated to test kind of on the outside, so they provide probes inside that allow you to kind of test behavior and see how a small part of it's working. And I think that provides a kind of an element of validation around this idea that we can test things at different level. We can test units and we can test components and we can do integration and we can kind of do acceptance tests. That actually, again, the dry thing isn't about making sure that we only kind of test one thing, but actually we can have different coverage in different ways because they have different effects. And that's not a bad thing. If we're testing exactly the same thing twice, that's fine. But actually, it's about feedback loops and things that run slightly quicker give us confidence. But effectively, that idea of having different levels is it works in the hardware world. So why shouldn't we do it in the software world as well? Tests are first-class citizens. We don't just test code is not something we kind of like rubbish and kind of get on with and move on. It needs refactoring. It needs tender loving care just as much as production code. We need to look after it and take care of it. Just because a test is written doesn't mean it doesn't need refactoring as it kind of evolves. It's quite easy to kind of say, mentally kind of think the important thing is I get the feature delivered, but actually the tests still need to represent kind of the behavior in the best way possible. They are kind of almost on equal footing. A practice which I first came across at university and really didn't kind of get the point of, but again has started to kind of, I think, has again gaining kind of a bit of traction, is mutation testing, which is about asking that question of who tests the tests. Slightly meta kind of question. And it's about perturbing production code to see what kind of things fail. And there are libraries, again, for languages like Java and C# that kind of will allow it to change code in interesting ways. But the way that I tended to have used it is more about, in a more manual kind of way, really. It's, when you come into a new code base and you're not quite sure what the coverage is over any particular feature, manually tweaking bits and seeing what happens and seeing how it fails. One gives you a good example of where things are. Actually, is this only tested at acceptance level, or is it unit level, or is there a bit here and a kind of a bit there? Or actually, if you change the thing you're about to change and no test fails, do you need to go back and add one or add something to express the current behavior before you dive in? So it's kind of a way of exploring the code base and seeing kind of how it sits before you kind of make that change. Or if you find that things structurally kind of don't make sense. So even as kind of like just at a manual level, just playing around with it is a useful kind of practice. Something as well that's kind of come out of the sort of the property-based testing world, which is kind of picking up traction a little bit more now, is this idea of thinking more about testing behaviors rather than in testing specific methods. Often when we start out with TDD, we do the kind of like the calculator example, and we had a test for add, and then we had a test for our subtract function. And then before we realise it, we've kind of gone down the path. We've got kind of large objects if you're doing something like OO, and all of a sudden all your tests are named specifically around the names of the methods. Because kind of like often there's a high correlation, but then you start answering questions like, how do I test a constructor? Or if you're in C++, how do I test a destructor? And you kind of like, these questions you don't realise at first, actually they don't kind of make sense because it's largely kind of irrelevant, because what you're thinking about is, it's the behaviour within the class. Some behaviour might not happen in the constructor, it might happen in some other method, but the point is what's the default object maybe look like is a different kind of question, or when you interact with it, what kind of happens. So thinking more about expressing behaviours in our tests rather than encoding the names of methods, which of course get changed by a refactoring tool, and then the tests get out of step anyway. So if you elevate them, the problem goes away. Executable specifications is a term that's certainly kind of growing. And this idea, again, that tests aren't just kind of a little bit of verification, but actually they are probably the most important piece of documentation that describes how the code actually, or how the system behaves, apart from obviously the source code itself. But answering any question about how is something supposed to behave. Those of you who've had like pages and pages of technical specifications where you have to look in version 1 and see how the feature changed in version 2, and then there's an annex to that one, and all that kind of stuff is all it's just kind of madness to find. Whereas now just going in, looking at a particular test that says how something behaves is kind of the best. It's a much better way of looking at it. And of course it's kept up to date because it has to be, as long as the test itself isn't kind of broken. So kind of elevating tests to being a formal definition, effectively, of how our system kind of behaves. Whether it behaves correctly or right or wrong is a kind of different kind of aspect. It's always, even though there are various people who have, ideas about the stuff, there is still sort of some conflict within the kind of, I guess, the community around what's the best approach to take, which particular, shall I focus more on unit tests or acceptance tests? And Cope wrote a paper a couple of years ago about why most unit tests are waste, which kind of really kind of like put the cat amongst the pigeons, I guess, and ruffled a few feathers, as he always likes to do. But it's kind of interesting getting people to think about, again, questioning our approaches as we go along and saying, actually, is that the right way to do it? There are other techniques like design by contract which seem to have fallen out of favour, perhaps, in some circles. As a consequence of kind of tooling and asking ourselves whether that's the right thing, or maybe that's still a skill that we should kind of keep going. Personally, I've never kind of been too happy with the testing pyramid, which you often see kind of trotted out, that kind of says we should have, a certain amount of unit tests and a certain amount of kind of integration tests and then kind of less end-to-end tests. And I'm kind of like, well, was it really a pyramid? Or, if you're working in kind of very small services, you might start with a lot of outside-in tests, acceptance tests around a service, and then only use unit tests for those kind of really tricky things that are really hard to reproduce, like if you need to cover what happens if you run out of disk space or you run out of memory. Some of those things are quite a bit harder. You might choose to do them much slightly different or express them in a different way. So therefore, I'm just going to commit to there being possibly a polygon that may be convex and is probably fatter-ish lower down than it is higher up, just because end-to-end tests are hard to write, they're slow to run. But the actual kind of balance, again, it doesn't matter. It depends what kind of environment you're working in. The terminology is as well self. Different people have different ideas what unit tests are, what integration tests are. I like Kent Breck's kind of like frames it more in kind of programmer tests. Does this thing do what I thought it should do? And then there's customer tests, which is, does it do what the customer wanted to do? And then there's kind of bits kind of in between. But effectively, those are the two sides, if you like, the two views of the tests that are kind of important. Okay, so the last sort of bit on, I guess, kind of on the motivational or the sort of psychology part is, I suppose, a tale where I kind of, for me, where I had to kind of like put the stuff into action I felt most uncomfortable about, was working on a big code base, C++, 10 years old, no unit tests. And I had to make a change within a component that was a heavily multi-threaded service. It had a number of other services it was dependent on. Even the kind of like sticking breakpoints in, trying to test code that way was going to be incredibly complicated and convoluted, probably going to take at least a week, of which days to set up. And so I decided to bite the bullet and to get those kind of first unit tests in place. I spent 3 days just sorting out hash includes, removing a couple of singletons, forward declaring types. I didn't even start kind of on the problem, just to get the code into a shape where I could even write one test around the existing behavior. And during that entire time, I felt massively uncomfortable because I was sort of lying to my boss and telling him that, actually, yeah, things are going great, yeah, doing a bit of this, but, so I got that done. I got the first kind of test in place, which was great. And then eventually I got a suite of tests, unit tests, over the class that I needed to change. And I found 5 bugs in an existing implementation. Most of them were edge cases that didn't crop up, but one of them was a leak of Windows handles, which had affected the reliability of the service. It was it was restarted every day because of it, or at least there was a problem and nobody knew what it was. That got fixed. And also there was a problem with large data sets over 4 gig, which was something that we were about to kind of run into. So I felt that I was justified in spending that time alone just because of what I managed to unearth around that particular thing alone. Then, of course, I made the change. That took about 2 hours, ran the tests, pushed the code into the test environment, formal test environment, and of course it worked kind of first time. But also, the other thing was that investment. Doing that meant that that effectively opened the floodgates. It meant that at some point we could write some more tests. And ultimately nobody had ever tackled it because it was too big a problem. But I decided that, you know, if I didn't do it, nobody else is going to do it. So. Okay, so that's all the woolly, wishy-washy kind of stuff, I guess. So looking back at those kind of like list of code smells, for the second half, I kind of wanted to go through some examples of, you know, what do they look like? What's the code that either I've written or I've seen other people, and how do I kind of think that they kind of can be improved? Something a little bit more practical. And again, to touch on one of the questions in the last talk about naming. So we know from the old joke that along with cache invalidation and off by 1 errors, naming is one of the 2 hardest practices in computer science. And it is. Naming tests is incredibly difficult. Naming the behavior, describing the behavior is something that is incredibly difficult. And I managed to optimize it away because it was so hard, first of all. But it wasn't until later I then began to appreciate the effects of that. And so I think that if you're struggling to name it, that's a sign. But that's a good sign. It's something that you should listen to. It probably means you don't really know what it is you're trying to do. I know some people are quite happy to just sort of dive in and, hey, we'll write some code and we'll see where it goes. And I guess I'm less convinced by that because I don't think that provides focus. I'd rather try and break it down. James mentioned the Arlo Banshee, where he starts with a name. You know, why not start with something that doesn't quite make sense? I think you can still start with something very small. It might be something you want to refactor. It might just be something simple of if I put null in, does the thing throw, or something like that. But just, you know, kind of taking that step, putting the thing in phrase, even thinking about from the client's perspective, you know, what is the thing going to look like? What kind of parameters might I want to pass to it? But at least kind of thinking within the context of some test. And then you can go back and refactor it kind of thing. So effectively, we need to think, we need to listen to it. We need to listen to that feedback and think very hard. The name is effectively an element of duplication. It's another way of describing it in more natural language, and it should tie up with what we then see in the test below. Test code is not production code. We often have coding standards, and for some reason we apply the same coding standards to test code that we do to production code. I'm not talking about tabs and spaces, but I'm talking about some things maybe around class names, method names and things. It's a different audience often, or it's treated in a different way. You know, tests are more of a narrative than the kind of like an ad hoc set of functions, and therefore it's okay for us to break the rules. It's okay for us to have a different policy around. Turn off your resharper inconsistent naming setting because it's going to get in the way. You know, the readability is kind of more important. We should feel comfortable with doing that. So, you know, by way of example, here is something I had to write recently, which is around a client component that talks to a service, and I want to test the reconnecting behavior. I've called the fixture, client automatically reconnects. It's sort of a nice, simple title to the sets of tests in it. And then at the top, I've got given the service is already running, and then we're into a sub-fixture because we're kind of going to split things out. We don't have to be quite so linear. We can, you know, divide things up. When the connection is lost, then it logs a disconnect event, and it reconnects in the background. Something that's kind of like nice and long, and kind of describes kind of, you know, what it is that we're kind of going to do. Now, I've used underscores here. If you use a language like F#, you can put real spaces in your function names as long as you use quotes, and punctuation. You know, don't be afraid to do that. You know, whether that kind of how that plays out in production code, I've not written in F# to know, but that's a language that allows you to do that kind of thing. And from a reading perspective, the IEEE, there's 2 papers in the last few years around the readability of variable names, where it was found that names with underscores are easier and faster to read. And that's just for variable names. For obviously for really long names, I presume that it's kind of there is at least a sort of a linear or an improvement. Anybody's had to read those horrible Pascal-y cased kind of long things, they're very hard. Use underscores. C#, it's not the normal practice, but this is a different, this is a different audience, so, make use of that kind of stuff. You'll see that it reads nicely from top to bottom because it's a narrative. It's about, there's kind of a bit of a beginning, a mid, and an end going on in terms of my story, what I'm doing, which you don't tend to have within a cast that's maybe with a set of methods. They tend to be a bit more ad hoc. This is very much a, read left to right, top to bottom, certainly in English. This is another approach. So the give and when thing, it's kind of a nice convention. I think it's a nice mechanical way of helping you to think about things and structure. But don't feel you have to stick to that. So I've kind of gone a little bit more, hey, a bit more hipster here with a bit of so and then and hey, this thing. So, because it's I'm trying to explain what's going on. I've used an extension method on strings, which I wouldn't do in necessarily, in production code in the same way. But what I want to do is I'd rather have real English words with punctuation in it, leaving the apostrophes out of don't because I can't have it in my identifier name. It's horrible. It's like trying to squeeze tweets in and you have to take a bit of punctuation out to make them fit to 140 characters. It kind of feels a bit irky. So, we should be able to make to find a way to, to overcome those because it's important that we get language in. So a tale about kind of like this idea of naming and I guess, the power of naming and language. And if you spend that time thinking hard about the names of things. I did some work a couple of years ago at a company who still used a mainframe. And they were writing in a mainframe, as an IBM mainframe, they're writing in their mainframey language. This is not a language that I knew. It even looked really weird. It wasn't a classic curly bracey type thing. But I was helping this guy kind of pick up test-driven development and unit testing. Although there had been a unit testing library for the platform for 10 years, nobody had kind of picked it up and nobody had kind of taken on because they hadn't been given the impetus to sort of wire it in. So we got this thing in, they did the calculator example, and then they wanted to move on to some real code. So I said, great, let's sit down, pick any piece of old code, and let's just write some tests for it and kind of see how it pans out. And so he started writing these tests for this little function that wrote some data. And as he was doing it, there was something that I kind of picked up on and I questioned because I didn't think that it made sense. But then he assured me that it was okay, it worked out. And then he came back to me the following day. And then he said, the thing that you mentioned yesterday, he said there's a bug in the code. So I've kind of, because I don't know AS400 thing and I could never write it, I've kind of done it in a C#, slightly more kind of, I guess, hopefully. He had these 2 tests. And the thing that I had picked up on was that in the name of one of them, he talked about success, and in the name of the other one, he talked about failure. And yet, the assertions, the things, the behavior, the validation was identical. And I said, that can't be right. You can't have 2 keys, it's a paradox. It can't mean success and failure. But it was a slightly weird language, so there's lots of asterisks and things around. So it could have been that I misread it. But what he'd realized, and he'd done subconsciously, is when he'd written the second test, he wrote it and the test failed. Of course, rather than questioning some 10-year-old production code, he assumed the test was wrong. So what did he do? He fixed the test to make it pass. But then when we went back and reflected on it and he looked at the implementation, he realized he'd based his test on the comment. But guess what? The comment didn't agree with the code. And that was why, things. And it turned out it was, although it was, bug in some very old code, again, it was an edge case that kind of didn't really sort of crop up. But in that one moment, this guy was kind of like, he was sold on the whole idea that, that how much stuff that they could get out of it. So from my perspective, it's using that kind of like double checking to say, does the language in the name agree with your expectation? So other ways that we can describe this kind of thing, where you have scenarios here. We have, You often get this list, and when you write them down, they all make perfect sense to why you've picked them. Come back a day or even a week later, and you have no idea, particularly if you weren't the person that wrote them. So I think it's fairly obvious that the first one is kind of empty. And then, second one has some punctuation. That fourth one, what is it about that fourth one that's wrong? Is it the fact that it's rounded brackets, or is it because it's square brackets? It's kind of, you'd have to go in and look into the code to see. Might not even be right, though. So what we can do is we can just introduce a bunch of constants. We can describe those trues and falses. It's not duplication. It's kind of, we can give those scenarios names. And again, we can put nice underscores in, and we can, make it nice and easy to write. Now it's obvious that that fourth case, what about it, is the fact that it's got white space, and that's the thing that's causing it to be invalid. If you're using an n-unit style framework, the last argument to your assertion is usually a message. So hey, why constrain ourselves? Why not just bung in an extra parameter on the end of our test case with a description of what it is? And then we can have punctuation in our message as well, which is it's like real English. If you use Cucumber, this is a common technique in Cucumber where you're defining tables of things, just having a redundant column, just with an explanation of why you picked those test cases, because I can guarantee you won't remember why you picked them later on. This is a kind of along the same kind of lines. I read a test where the expectation is around, it talks about service unavailable, which if you've done HTTP at all, you'd know that service unavailable is usually 503. So now I've got a question is the status code in the test wrong? Or is it the name that's the test wrong? Or actually has somebody fixed the production code to make the test pass? I don't know, there are so many different kind of things because all the things don't kind of quite add up. And it turned out that actually it's none of those. They just wanted to pick a code in the 500 range. It doesn't really matter. Any of them would have do. So lifted it out, said, this is just an indicative example. I mean, we could have tested every case in this particular instance, but effectively this was a kind of a higher level test. And then I changed the name of the test to try and be a little bit less, not pick something that is a specifically named HTTP code that has a particular name. I'm not sure I've quite convinced it, but it's trying to kind of fit it on the slide. So again, trying to make things more revealing. The one behavior per test. So we have this thing around multiple asserts within a test. And I think, in some cases we've kind of lost the reasoning behind that. It's a heuristic. Because we might have tools, people start building tools around, make sure that, it points out that you've got more than one assert, but we kind of forget, why we kind of got there in the first place. And it's the reason why multiple asserts is seen as a smell is because it might be that there are multiple behaviors that we're trying to test. So in this particular case here, we've got some calculation that's going on, and yet we seem to be looking in a log file for some particular event. And that feels like, how is that related to the calculation? That's a bit kind of weird. Another example is the word and. Again, in the name, if somebody puts that word and, or you find yourself writing the word and, ask yourself whether is this two separate behaviors that I should be dealing with? And it probably is. Split them out into two separate things. So the calculation is one part, things about instrumentation is an entirely different behavior. It's a lot easier to just shove another assert on the end of an existing test. The temptation is great, but, be strong and think about whether you should factor that out. Again, James had two tests where, in his slide where they were very, very similar. That's not a problem because they are different. The name should make it obvious that there are something around them is slightly different, and you should be able to tie that up. Cases where you do have multiple asserts is just if you have a complex return type. Here we've got a kind of if you're returning a tuple or something like that, you may have multiple asserts. So it's not a bad thing. It's just remembering that the thing that you're writing your asserts for is all part of the same behavior, or whether it's kind of different stuff. Again, tautologies. This is kind of thing, I don't think anybody would ever write something as blatant as this, where they actually call the same code in their assert of the function that's kind of under test. What normally happens is it's hidden a little bit more. So here, in our production code, in our test, we're actually under the covers, we're using some piece of the implementation to help format something where we're actually involved in what we're trying to assert the behavior. This is where the mutation testing comes back in. If I was to change the format function and get it to return, say, a null reference, this test would still pass, and yet I have broken the behavior. And that's because we've depended on the same thing. The test is kind of reinforcing. The test is using the same code under the covers to do the same thing. and that's not good, you know. So going back and making sure that that kind of thing behaves. Actually, it might have just turned out that we didn't really care what the actual value is. This is can often come out when we're trying to avoid brittle tests. We're worried that, you know, if somebody changes this thing, that this thing over here is actually, you know, going to change, is going to fail, and it's going to be noisy. So if we use the same thing, then the test will obviously pass. It won't, the behaviour effectively won't kind of change it, won't cause it to fail. But actually, really, we've just overly specified the behaviour, or under-specified. So another technique might be to go further down into the code. And actually, if a thing is around you know, the generation of an ID, maybe we need to drill further down and say, the reason we did that was because we've got this non-determinism elsewhere, and we can mock that non-determinism out. So there's other ways. And we'd be a little bit looser here. Just used substring rather than an exact match, using other things. So I'll skip those. So yes, so here's an example of where I don't care what the format of the date and time is exactly. I just care that the date, the time, and the month are in there. So I'm trying to give ourselves a little bit of wiggle room. If I don't actually know whether it has to be ISO 8601, but I know those things need to be in it, trying to a little bit be less prescriptive. It makes the code a bit more verbose, but it gives us more wiggle room. How do we have time? Right. So I've left in, there's loads of other some other examples and stuff, and I've left most of them in because they are, you can kind of look at them if you want to. But I'll just head to the the last bit around my last example, which is about unmanaged resources. This is this thing that often we have things in our process that live forever. We don't really care about them. But when we're trying to run a test, we're trying to invoke the same behavior again and again. You know, we often end up with tests that fail or random other tests. This is an example of something that actually cropped up recently where we needed a background thread to do something, which is kind of great in the production code. You can just forget about it, but it doesn't work in a test scenario. If you spawned it or if you created it and it's a resource, you have to manage it if you want tests to be able to be predictable. You need to be able to shut things down. You need to put the system in a known state. You need to be able to tear it down again and go back to a known, go back to that base 0. So it's important that you manage things. This is what design for testability is kind of about. You're adding extra code that you don't need in production, but it allows you to test your component. So here, I've just taken the approach of holding on to the background thread and adding a dispose method in to make sure that I can clean up in my kind of text fixture. So it's code I've added to make the code testable in a safe way. Or I can even change the design and say, well, actually, the backgroundy bit is independent from the actual threading part. You know, maybe change the design, do something different. Either way is kind of applicable. That's about sleeping in tests. So, yeah, so you can peruse some of the other examples if you want to. So as a kind of like a last thing, kind of going back to the kind of the motivational side of it. You know, continuous delivery is a big part of what people are trying to adopt. And, you know, good quality tests are definitely kind of integral to that happening, that kind of sustainable pace. Extreme programming, if you've kind of read the book from Kent, he talks about there is these 5 values in XP. And effectively, they all kind of like reinforce each other. And I think that, certainly from looking at it from a testing approach, of the other values there, so there's communication, so it's important that our tests can kind of talk to us and tell us what the expected behavior is and kind of what they're doing. Simplicity is about us writing only what we need to write to satisfy the feature. Let's not write lots of extraneous code for any reason. Let's just, you know, do what we need to do and kind of no more. Respect is probably a little bit tangential, but we should respect the code. We need to look after it. We need to refactor it. We need to make sure that, you know, it's given some TLC. And obviously feedback. You know, the whole point of doing this is to provide us with quick feedback to tell us whether what we're doing is right. Both from are we satisfying what the customer wanted, but is it also doing what we kind of need it to? And I think the outcome of that is effectively the 5th value, which is about courage. What we need to do. We want that confidence in what we're doing in that feature. If we want to push things quickly, make changes, move fast and hopefully not break things, but if we want to do that and create a pace to which we can sustain, we need courage. We need to be able to lean on something, and tests is the thing that kind of gives us that, in my opinion. That's it. That's the end. I don't have a book to plug, but most of what's kind of in there is in some blog posts and some articles. That's it. I'm around. I mean, you can go for lunch if you want to. If there are any questions.